Hello students. Today we are going to discuss from your textbook. This is your book from Finite Mathematics. We try to explain something about break-even points, and a little later I can discuss about the demand-supply equations. So before I start to say anything about these two subjects, I would like to go to a little of terminology about a revenue function, which in fact would be a function of x, and that would be, in general, when you put x, therefore we have to assume x on the right side. If it's q, maybe if it stands for quantity is better. R of q is equal to price of each item, which is small p, times the number of items. The number of items would be q, quantity. As I said, sometimes some books they use x instead of q. And also we have a profit. In general, we can write revenue and cost, then profit. Cost usually is a linear. Linear means actually is just a first order. The order of x or q is equal to 1. Therefore, one could assume as mx plus b or mq plus b, that m and b are real numbers. Therefore, what we have now is a profit as a function of q. As a result of cost and revenue, we have profit function, which is nothing but revenue minus cost. I give you example so that you will understand it better in terms of numerical. Assume that you are trying to buy 5 items, let's say 5 notebooks, and each notebook is about $2, and then 5 times 2 becomes $10. That $10 is your cost actually. And assume that after a while you are going to sell it. Let's say you are selling it for $12. That $12 will be your revenue. So then profit is nothing but revenue minus cost, which means 12 minus 10. And 12 minus 10 would be, that's your profit, which is equal to $2. There is another case which you borrowed for $10, and this time you're not selling $12. You're selling less than $10. Let's say $8 or $7. So then what you have is actually 7 minus 10, which is equal to minus 3. Your profit is not the profit. You will get something, it's called loss. So in this case, you will have loss, not profit, because it's negative. The negative is telling you. So the case that we are going to discuss today is coming from here, that actually when the case that C is not bigger than R and C is not smaller than R, but C is equal to R. When C is equal to R, then in this case, the point that you are finding, the value of Q you are finding, and then behind that you will find P in terms of Q. That's called break-even point. In other words, you bought it for $10, you sell it for $10. So what you have would be 10 minus 10. So that's your profit. Profit 10 minus 10 means 0. So that's the point, that if you have your cost function and if you have your revenue function could be a curve like this, for instance. If the revenue is bigger than cost, which is in this area, that would be your profit. If the cost is bigger than revenue, that would be loss. So in this area you have a loss, you are losing money. In this area you are making profit, this area. So always is good that the revenue be above the cost. Cost is below the revenue. All right, this is just a numerical example. It's a very simple terminology that I use. So it is better to use P and Q rather than P and X. But some books, as I said, they use P and X, like this example that I have here now, they are using X rather than Q. But again, it's up to you if you want to change X to Q. Q stands for quantity, number of items, and also X would be the same. Number of items, number of the unit that you are defining. If you are producing TV in your factory, for instance, number of TVs, that would be the quantity, the Q. All right. So to get the break-even point, I have to show you by solving one example, and the example actually comes from example 7. Example 7 from your book. As they said that we have cost function that's given to you, which is 250x plus 213,000. So you have C of x, and also you have revenue. Revenue also is given to you, is equal to 550x. So you have cost function, revenue function. Both you will see it in this case. Actually, revenue also is a linear. Both are lines, so you don't get a curve on a line. Both are line. Is even easier. That's a simple case. So to get the break-even point, which we discussed, therefore we should do this. We should let C of x to be equal to R of x, or R of x is equal to C of x. So it's the same thing. When you write R of x is equal to C of x, then what happens is R of x is 550 of x, and that C of x is 250 of x plus 213,000. And if we try to solve this for x, therefore what you are getting is taking this 250 to the left side, or subtract 250x from both sides, so you will get 300 of x is 213,000. Therefore, if you divide both sides by 300, this will give you x equals to 710. So this is actually x, or q, as I said, is the quantity that you will have. Therefore, if you want to look at it, that's x. But if you could substitute in R or C, either one of them, it doesn't matter, you will get the same answer for C at 710 or R at 710. Both will give you the same value. Therefore, if you look at the picture that I have here, that I have the picture of R of x and I have the picture of C of x, they intersect each other at the point. That point is called break-even point. That's the point when R and C, they reach to each other at the point, they have a point of intersection. That point is called break-even point. So we try to find that point. Here, if you look at the picture, when they have a 710, that means x is 710. So this will be actually your x is 710, is smaller than 800. And then you take this 710, as I said, substitute either in C of x or in R of x, then you should be able to find from here to here. From here to here, which is about 39,500. So you will have two values, and that's the point of these two values, and that's called break-even point. So it's just a matter of if you have the company, for instance, here the company, they're selling TVs, as I said, because this is problem 7, example 7 is based on example 6, and they have a company of manufacture which they are producing 65-inch of a smart TV that sells to retailers for $550, and the cost of making X of these TVs, the number of TVs that they are producing for a month, is given by this function. That's a C of x. Therefore, if I substitute anything, x equals to 710, then my break-even point would be for x equals to 710. But if I go above that, if the factory, they produce it large amount, if they produced anything bigger than 710, then of course you will see that you will get the company must sell more than 710 TVs in order to make a profit, because other than that you will not get your curve above, your curve of R of X is not above the C of X. So here in this region you can see the red line, as long as red line is above the blue line, this is the region that you make profit. But if the blue line is above the red line, then this is the region that you lose money. That's a loss. So you must go above 710 to produce 711, 712, 720. Anything bigger than 710, then you make a profit. All right, so this was just the first things that I would like to discuss it with you. There's another subject that I'm interested again in this section to be discussed, and again both again would be similar. Here again we got to solve a system of two equations, similar again, but what we have is called demand equation and supply equation. In both equations, as I said, you will have Q rather than X is okay if I substitute Q instead of X. Therefore, what I have a demand function. In this case, the demand function, for example, 8 is P equal to 60 minus 3/4 of Q. So that Q is a demand, actually. And P is the price. Small p is the price. Make a notice that a small p is different with capital P that we use it for profit function. So we have the function which is in terms of x. Therefore, when you substitute for x or here q, then you should be able to find p. So the question is this. In economics, suppose that economists has studied the supply and demand of aluminum sidings and has determined that the price per unit, small p, and the quantity demanded, small q, are related by the linear equation. So this is a linear equation because p and q, they don't have any other power than 1. If it's anything else, then that's not linear. That's called non-linear. So in this case, what we have is the question that they're asking, find the demand from this equation. This is the equation is given to you. This is the demand function. The Q is demand. Therefore, when they say find the demand at the price of $40 per unit, so you substitute simply for P to find Q. How much is Q when P is $40? So when you put 40 here, then 60 minus 3/4 of Q, then try to solve this for Q. This equation, first order linear, is not very difficult. It's simple, but you got to pay attention that you have to isolate Q to find Q. So here what they did is they subtract 60 from both sides, or move this 60 to the left side, so it would be 40 minus 60, which is minus 3/4 of Q. And then what they did, they multiply both sides by 4, because this is minus 20 is equal to minus 3/4 of Q. Or simply divide both sides by negative 3/4. That negative becomes positive. So what you have is actually 20 divided by 3/4. 20 divided by 3/4, which is actually 20 times 4/3, and that will give you the answer. So what you have here is the answer will be 80 divided by 3. That's 80 divided by 3. 20 times 4 is 80. 1 times 3 is 3. So it will be 80 divided by a little bit more than what they found. I think they found a little more than 26 and 2/3. So here Q is about 26 and 2/3, a little more than 26. So 26, if you can produce a little more than that, like 27 and so on. So what happens in this case, that's part A. Part B, they say, find the price if the demand is 32. So now they say the demand and they ask you, can you find P? So in the same equation that we already had, now this time you're going to substitute for Q. So that's a part B. Find the price. P is how much? Equals to 60 minus 3/4 times Q, and Q is given to you. Q is equal to 32. So 32 units, 32 items you are producing, and substituting by 3/4, and then subtracting from 60, and that will give you the answer. That would be like 60 minus, this is 8 times 3 is 24, and that would be 32. Right? That would be now 36. I'm sorry. That's 36. That's 36. And that's the part B. And part C is graphing. That's a linear. We have a P and Q. And therefore, we can draw a graph for that by having only 2 points, x-intercept and y-intercept. So here, instead of x and y, what we have is Q and P. Q is x-axis, and P is y-axis. Therefore, if you have 2 points joining these 2 points, then you will get this line. That's the line, is the graphing. We go further again. They are having similar questions again. If the price is $30, can you find the quantity is demanded? If the price is 60, can you find the demand? If the quantity is demanded at a price of $60, how much is that? That quantity? How many quantities do we have if price is $60? So things of this type of this nature is called demand equation. Something similar to demand equation also we have is called supply equation. So supply equation would be again a relation between P and Q. That's the demand. This is supply equation. And in a supply equation, that for instance in example 9 that I have, they give you a supply equation. The economics problem, suppose the economics is example 8. They have this supply Q of siding is related to its price P by the equation P is equal to 0.85 Q. So P is equal to 0.85 Q. And that is the supply equation. Question, can you find the supply if the price is $51? Price is 51. So you substitute $51 and 0.85 times Q. Question, can you find Q? Yes. Q means 51 divided by 0.85. And if you do that, 51 divided by 0.85, and using your calculator, and you will get the answer Q is equal to 60. So Q becomes 60. So as you see it, again, similar type problem that if they give you P, you can find Q. If they give you Q, you can find P. And if you put these two problems together, the first one was demand equation, the second one is a supply equation, then we will have this picture. This blue color is the supply equation, and the red color was the same problem that we did it before. Now is a red color, and that's a demand equation. So both can be done in the same system. System that we have is a QP system instead of XY system. And here again, we will have a red line here, as I said, and you have a blue line which passes through the origin. So this point is the point that we are interested in. This point is actually for the same P. P is the same for both of them. So if you have two equations, which they have it here, one equation is 0.85 Q, and second equation, which is called demand equation. Demand equation, it is 60 minus 0.75 Q, and that's equation 1, that's equation 2. And you have this line for the demand, and you have this line for supply. So if you solve this system, in other words, if we write it down, that P is equal to 0.85 Q, and P is equal to 60 minus 0.75 Q. After solving this system, you should be able to find Q and P. How do we solve these? The easiest way to solve this by substitution. Actually, you could do it by elimination method, by any method. If you do it, then you should be able to find Q. So by substitution, since left-hand side both are P, it's the same P, therefore right-hand side must be the same. 0.85 Q must be the same as 60 minus 0.75 Q. And then we solve these for Q, and when you subtract from both sides, 0.75, I'm sorry, by adding 0.75 to both sides. Therefore, what you have is 60 is equal to 1.6 Q. And then you divide those sides by 1.6, get rid of this 1.6. Then Q becomes finally equals to 60 divided by 1.6, which if you use your calculator, you should be able to find the answer. Q is 37.5. 37.5. So that's the Q is the number of item. And then once you have a Q, you have two choices. You have either this first equation or the second equation. You plug in Q here, and then multiply 0.85, that will give you P. So if we do that, therefore P becomes 0.85 times Q, and Q is this much, 37.5, which in fact is nothing but 31.875. So this Q and P both together is actually this point. The point is QP. Q is 37.5 and P is 31.875. This is called equilibrium point. So equilibrium point is the point for which P of both of them are the same thing for this. And that's the P. And if you look at the picture also, it makes sense. P is 31.85, and that's the P is from here to here. From here to here. So you will get 31.85. 31 it would be from here to here. So 30, a little over 30, that would be 31 almost. Then you go to find the Q. Q is again from the same point of intersection. You come down. It's pretty close to 40, you see? So you will get the Q is equal to how much? Q was 37.5. So these two together, 37.5 and 31.8, it will give you a point, which is a point of intersection of the price of both supply and demand, and that's called point of equilibrium point, the inequilibrium. And that's all I think I had for today, and I will see again. We can do something for the next time, next section. That's what I think I have for today. Have a nice day, then I will see you next time.